This video goes over the examples for solving trig equations. So when you're solving an equation, you're looking for all the values of x that make the equation true. And we are going to look at between 0 and 360. Okay, Mr. Shaw's video has the example where you are working in radians. So the first thing I'm going to do is rearrange for cos x. Okay, I get cos x is equal to minus 1 over root 2. I'm going to set up my quadrants. I know that cos is negative in the second quadrant or in the third quadrant. And now I'm going to find my related acute angle by taking the cos inverse of 1 over root 2. Now, red flag right here, remembering my special triangles. Okay, I've got 45, 45, 90. Okay, I know that my related acute angle here has to be 45 degrees because it's from one of my special triangles. So then I can go to finding my solution in quad 2, which would be 180 degrees minus 45 degrees, which is going to give me 135 degrees. And then in quad 3, I'm going to have 180 plus 45 degrees. Right? And so x is equal to 225. Okay, let's do another example down here with sine. So I'm going to rearrange for sine x. I get root 3 over 2. I'm going to draw on my quadrants. I know that sine is positive in the first quadrant and in the second quadrant. So the next thing I'm going to do is find my related acute angle. My related acute angle is found by doing the sine inverse of root 3 over 2. But hold on, I'm going to remember that I still have a special triangle here. And my special triangle is going to be the 30, 60, 90, where I've got 2, root 3, and 1. So I know that my related acute angle here has to be 60 degrees because that is the one that matches with that ratio. Once I have that related acute angle, I can go ahead and find my solution in quad 1, which is just 60 degrees. And I can also find my solution in quad 2, which is 180 degrees minus 60 degrees, which gives me 120. The last example that I have here looks a little bit different because I can't rearrange it to get sine x by itself. What I can do, however, is I can factor it. So I can write this as 2a squared minus 3a plus 1 equals 0. And then what I can do next is I can now factor this expression. When I do that, I'm going to get 2a minus 1 and a minus 1. And then I can just replace my original sine x back in here. So I've got sine x minus 1 equals 0. And now I've really got two questions that I need to set equal to 0 to and solve. So the first one looks like one I've done before. Sine x equals a half. Drawing my quadrants. I know that sine is positive in the first two. I am looking for the x value that makes that ratio true. Using my special triangles, I know that that's going to have to be 30. Okay, using my 30, 60, 90 triangle. That means that I have my solution in quadrant 1 as x is equal to 30. And then I've got my solution in quadrant 2 as x is equal to 180 minus 30, which is going to give me 150 degrees. My second expression here, now I've got sine x is equal to 1. So I am looking for the values here, not so much where sine is positive, but I'm looking for where my y value in my sine ratio is at a maximum. Okay, that is going to happen really at only one place. Okay, and that is if my terminal arm lies right on this boundary between Q1 and Q2. Okay. My y value is at a maximum because it continues increasing all the way to that point, and then it decreases on the other side. If it was down below on the 270 line, then I would get a negative value. So that means my solution here is x is equal to 90. So my three possible solutions for x are 30, 90, and 150.